Hello everyone and welcome to PC Retro Tech. I know what you're thinking, he's gone mad. He's making an entire show about the floppy drive. This is going to be boring. But you'd be wrong. This is not an entire show about the floppy drive. This is an entire show about the 5¼ inch floppy drive. And the reason I'm making this is because over the last couple of days I've been working with these things almost constantly and discovered that I knew almost nothing about these devices. So I want to share with you today some of the really interesting things that I discovered while trying to repair and install floppy drives. But first of all, let me explain what the problem was. So those of you who watch the channel know that I don't just enjoy retro computing, but also retro programming. I like doing 8088 assembly language programming, and this is my XT clone. It's got a CGA graphics card in it and a full 640 kilobytes of memory. I mean, that should be enough for anyone, right? Well, it's really quite the experience, but if something went wrong and the machine died, I could lose 3 months of hard work. Now, I could back up to floppy. It's got a 5¼ inch drive in it, but if you know anything about the reliability of floppy media, it's just not an option. So I thought maybe I could install an iMega zip drive. These reportedly install almost anywhere. But there's a problem. These don't work on 8088s. For reference, this works just fine with a V20, but it doesn't work with the original 8088. So that's out of the question. I don't want to put something anachronistic like a compact flash adapter in this. I like working with retro machines because of the feeling of working with the original hardware. So I really am stuck with that 5¼ inch drive. So what I've been doing is taking files from GitHub on the internet across to a 3½ inch drive in this Athlon machine. And it has a modern operating system on it, so it's secure to use online. Then I copy the files across to 5¼ inch disks on this Amstrad in the corner here. And then finally into my XT. Now there's an obvious optimization I could make here, right? I could put a 3½ inch drive directly in this machine. But there's a couple of problems. First of all, the floppy drive controller in this doesn't support any kind of high density drives at all. And secondly, there's no 3½ inch bay in this machine. And there's a reason for that. These machines didn't have 3½ inch drives in them. So I am really better off doing something at the other end. Now this machine until recently had Windows 10 on it, and I can honestly say installing it was a bad mistake. I have nothing against Windows 10, I have it on my laptop. But this machine takes 5 minutes to boot up, another 2 minutes to start a web browser, 2 minutes to copy a file onto a disk, and then another 2 minutes to shut down. And that's if Windows Update is not running, which it always is. So this weekend I went back to Windows 7 on this machine, and now I can boot from a cold start to a web browser, copy files across to floppy in just over a minute, and then it's only another 30 seconds to shut the machine down. What an improvement. So the obvious solution to my problem is just to install a 5¼ inch drive at this end, right? Well, that's what I thought too. It should be an easy job. But it was the beginning of a learning experience that I want to tell you about in this video. So the first thing that I did was to go through all of the 5¼ inch drives that I have spare that aren't installed in my working Amstrad machines or in the XT itself. And I went through them all one by one to see which ones would work, and I was really surprised to find that none of them did. And I started to scratch my head and I thought, well, maybe the machine is faulty or the floppy cable or the controller or something. So I switched everything over. Same result. Now I know that you have to clean the heads in these things. You get some isopropyl alcohol on a Q-tip or a cotton bud, depending on where you come from, and you clean these things. They're the heads that read the data from either side of the disk. It didn't make any difference in this particular case. I also know that some of the disk drives have rubber bands in them, and they look like this, and they can denature over time. They can become hard and brittle and break, or they can stretch and then they don't turn properly. But this is the only one of my drives that actually even has a rubber band in it, and the band itself seems quite new. So that wasn't the problem. So I had a look online to see how much does a second-hand 360 kilobyte 5¼ inch drive go for anyway. Maybe I can just buy a new one. But the prices are like 80 to 240 euros. And so then I really started to think, oh, these are really unreliable and it's really hard to get working ones. It's very surprising. It's easy to get a drive. Just buy any old computer case and it's probably going to have a 5¼ inch drive in it. That's where I got a lot of these from. But it seems that perhaps people just put faulty ones in to fill a hole or something like that. So I could start to see after some time why people install compact flash adapters. If this is going to be how much trouble they're going to be, maybe the compact flash adapters are better. But here's an example of where I think someone's had trouble fitting something into this floppy bay from my Amstrad, and you can see they've mangled all the metalwork here to get whatever it is in, and I have a pretty good guess of what it was that they were trying to install here. But are these drives really that unreliable? Or is there something that I just didn't understand about 5¼ inch drives? So the first thing that I learned about is calibration. So floppy drives like to spin at either 300 or 360 revolutions per minute. And some drives even have a calibration wheel printed on the bottom. And it looks like this. There are two rings of figures printed on the drive, one labelled 60 and the other one 50. And the idea is that you look at this under, say, fluorescent lighting or something flashing at the speed of the electric supply, which is either 50 or 60 Hertz, depending where you live. And when this pattern stabilizes and doesn't look like it's moving anymore, then you know that the drive is spinning at the right rate. And so there's usually some kind of screw adjustment or a potentiometer or something that you can adjust to get the speed exactly right. Unfortunately, none of the drives that I have either the calibration wheel or an adjustment that I can find. So it wasn't able to calibrate any of the drives. I think this is really more common in very, very old floppy drives, and perhaps it's more common on 8-bit machines than on 16-bit ones. So the second thing I learned about is software for testing floppy drives and their controllers. And the one I want to look at is called Image Disk, often just referred to as IMD. And you can download this from a website called Dave's Old Computers. And there are a few utilities here, including this one called Test FDC. And basically you give it a drive letter and the kind of drive that you want to test. So I'm going to do A: and a 360 kilobyte drive. It'll ask you to insert a disk into the drive and then the test begins. Now be careful because it will write the top 5 tracks to the disk, so if you don't want your disk destroyed, don't put it in this test. Now you should be able to boot from the drive because the boot sector and the command com and so on won't be in the top 5 tracks of the disk. But it'll run through, and as you can see it's going to test the different data rates and densities that the drive might support. In this particular case you can see that at 250 kbps at basically any density or layout we get failures. So there's an address mark that it couldn't find a sector and so on. Now I know that the disk that's in this drive is fine, I can read all of it in another machine, but you can see that the tests it has run have failed, and so that's an indication that something is not right here with this machine. So the main utility here is IMD, and I recommend reading the help because it's quite a complicated little utility. So press escape to get out of the help, and the first thing you want to do from the main menu perhaps is the RPM test, which is T, and it'll ask you to insert a disk, and then it's going to try and figure out what the likely data rate of the disk is, and it's for some reason picked 300 kbps here. Also, it's a little bit odd that the revs per minute is sitting around 360. We would expect those numbers to be 250 kbps and 300 RPM for a 360 kilobyte drive. So this is actually not a calibration issue, but it is a big hint as to what's going wrong here. So if I go back to the main menu and press A, it'll do an alignment test. And it's going to start off at track 0 and it's going to start reading sectors, whatever happens to pass under the head when it does its test. So the first column is the track that I'm on, which is 0, and then it's telling me the sectors that it's reading, which are changing very rapidly of course as the disk spins. and it looks for little identifying marks to tell it what track this should be, and it's getting 18 matches. Now of course there are only 9 sectors on a track here, but it's obviously spinning twice for each test, and it looks like everything's doing fine here. We're getting 18 sectors that are reading correctly. So the final column is just the number that didn't match, and of course this is 0 at the moment since everything is going well. So now if I press H, it should change to head 1, which is the other side of the disk, and you can see that it tells me that it can't read anything at all, which is a bit concerning. So let's go back to head 0, and now I'm going to increment the track. So of course the head will have to move a little bit to do this. It's called a step. So press 1 to go to track 1, and indeed it does. But now it's telling me that it's not getting 18 matches anymore. It's getting sort of a random number of matches. But there are no non-matches. At least everything that it does read is track 1. But when I press 1 again, it now tells me that there are 18 non-matches. So it's not reading anything from track 2 here. It's still reading stuff from track 1. And of course nothing matches track 1. So now I press plus again. I should be on to track 3, I think, and it's now just random numbers of matches for track 2, but then if I press it again I get no matches and so on. So this is a little bit disconcerting. It doesn't seem to be picking up the correct tracks. Now the reason for this is that there are 2 kinds of steps that a head can take. There's single step and double step, and it turns out that this diskette is formatted with double step. So I'm going to press the S key, and that'll change from single step to double step, which you'll see in the upper right of the screen. And now when I press the plus key, it'll tell me I should actually be on track 5 here, or at least I'm reading track 5, and there are 18 matches. So it seems to be reading track 5 just fine, and if I press plus again it'll go up to track 6. You can see that there were just 12 matches on the first go around, but after that it settled down, everything was fine. So it looks like changing the step rate to double step has worked there. So this tells me now that I have 300 kbps data rate, 360 RPM, and double step. And of course I could go through and seek all the tracks and check whether there's 40 or 80 tracks on the drive. And of course when I get to the very outer part of the drive it's just going to start giving me garbage because the disk could have been formatted many times in many different ways. So when I go back to the main menu here, the other option that you want to look at is C, which is for cleaning the head. And it'll ask you for a number of passes and eventually to insert a diskette. And the idea is that you'll insert one of these disk cleaning disks, and it's basically just a disk with a slit in the top. You could probably make one of these yourselves, and it's got a little hole here and obviously the big hole in the center for the main hub. The idea is that this material, it's not paper and it's not plastic, it sort of feels like it's somewhere in between the two. It's porous. If you put alcohol on it, it'll go straight through. But the idea is that this won't leave anything inside the drive. There's no lint or anything. It's not like a soft material. It feels like kind of like a plastic tablecloth or something like that. If you don't have one of these, of course, you can just revert to the old Q-tips and isopropyl alcohol. But the idea is you put alcohol on this and insert it in the drive and it'll clean the heads. So the next thing I want to go through is drive jumpers, and I encourage you, if you have any working 5 1/4 inch drives, write down the model numbers and the jumper settings in the comments below. There's a real shortage of good information about correct jumper settings for 5 1/4 inch drives. And very often, even if you can find the jumpers documented somewhere, it's cryptic and you have no idea which setting you should use. So that actually explains what's going wrong with these drives. These are the PY261B and PY261C, and they're both almost identical. They're branded Amstrad, and in fact these are out of an Amstrad PC1512. And the reason this doesn't work in a PC is because the PC jumper settings are different. So it has at the bottom here a 3-pronged jumper. At one end it's got DS and at the other end MX. See what I mean by cryptic. And then there's some numbering 0 through 3 for all of the other jumpers. They're all just 2-pronged jumpers. And it turns out that the 0 through 3 are, if you like, drive select jumpers, and these are normally labeled DS0 through DS3. Sometimes they start the numbering at 1, and so you have DS1 through DS4. And sometimes there's only 2 of these. Maybe there's just DS0 and DS1. Here they're just labeled 0 through 3. And the DS and MX stand for drive select and multiplex. So the main difference with the PC settings is this jumper should be set on setting 1. The PC always takes the second setting, not the first setting, whereas the PC 1512, the Amstrad machine, takes the first setting. So again, if you had numbering DS1 through DS4, you would set it on DS2. In most drives, it's numbered 0 through 3, and so you set it on DS1 for a PC. Now, the DS and MX stand for drive select and multiplex. And if this was set in the drive select position, then the other jumpers just don't matter at all. They're ignored, and it just says that this drive is selected. And this will work fine in a single drive system. But once you have 2 drives, you want to select the multiplex setting, and then of course you must make sure that both drives are set in the second position for a PC. Now that's a little bit strange. You might imagine that it makes more sense to have the drives with different numbers. But that's not the case. You want them both set to multiplex, both set to the second position. And the reason for that is because the cabling selects the drive. At the end of the cable you have drive A, and in the middle of the cable you have drive B. And there is a twist in the cable to enable the machine to distinguish the drives. Now you have to be very careful with these cables. First of all, pin 1 is usually red. The cable corresponding to pin 1 is red, and pin 1 is near where the gap in the connector is. So you want it this way around, with the red towards the end with the gap. Now sometimes the connectors have a little plastic notch in there which prevents you putting the cable on the wrong way. But this is not that common, and it's very easy to get it round the wrong way. Not that it will matter, it won't blow anything up, it just won't work. So the other thing to watch out for is that not all cables that fit on this drive are actually floppy cables. So this is another cable that looks very, very similar. It also has an "and" in the middle and a red label, and it actually fits just fine on this floppy drive. But the issue is that this is a hard drive cable. It's an MFM drive cable, and the difference is that on the floppy cable you can see that there are quite a few more wires before you get to the twisted part. If there are only, 5, I think, wires here before you get to the twisted part, this is a hard drive cable. So how many floppy drives do you think you've tried to use that haven't worked because you had the wrong cable? So the next drive I want to have a look at is another Amstrad drive, as it happens. It's part number 40046, also known as the PY341C. And I believe that this is, again, from a Amstrad PC 1640 this time. And setting this up is dead simple. You just change from 0 to 1, and away you go. And in fact, this is all you can change on this drive. There are actually 2 other jumpers here. There's the usual DS-MX one, but it's hardwired to DS. And on very old drives, it's not uncommon to actually have to cut wires in order to get a change of setting. Not that you probably want to do that, although this is obviously only set up to run as a single drive. Now the other setting is MS and MM, and it's currently hardwired to MM, which really just means that the motor is turned on whenever the motor on pin for this drive is selected. And when that goes high, the drive will start running. Obviously, that's not on all the time. If I select the MS option, then the drive select pin would actually control the motor. And if this was a single system, then you might expect the drive to just run continuously. And if there are multiple systems, the drive would run whenever this drive is selected. That's generally not what you want. You only want the motor to come on when the motor on is high, and that is the MM. Now those pins are actually right next to each other. In fact, they're in the part of the cable that's twisted here. The drive A is at one end of that and the drive B at the other end of that, and the two pins are right next to each other in each case. By the way, if you have a MFM hard drive cable instead of a floppy drive cable, you can actually get a floppy drive to work on it. Of course, the first part of the cable is identical to a floppy cable, and so you can use that. But of course, in a PC, you normally have the first drive at the end of the cable rather than in the middle. But it's no problem to run a drive in the middle. You just switch back from 1 to 0, and this is precisely the reason that the Amstrad actually uses 0 instead of 1, because there is only one connector on their drive cable which has no twist. So the next drive I want to look at is this Chinon FR506, and the jumpers for this are around the side here, and they're very small jumpers. They're not standard size at all, and very helpfully they're labelled somewhere else, namely in this little window around the side here, and if you didn't know that, you wouldn't find them. At the very end here is the TM jumper, and this stands for termination, and it switches in a little resistor pack which should be for terminating the cable, and so the very last drive on the cable should have this enabled and the other drive should not. And so normally drive A is the last drive on the cable in a PC anyway, and so you would normally have this selected for drive A and not selected otherwise. The next 4 pins are DS0 to DS3. These are just the drive select pins that we've already discussed. Just set those to drive select 1 for the standard PC arrangement. The next one is labelled IU, and this is a bit of a tech joke because it stands for in use, but ironically it's never actually used. So you can just leave that jumper off. The next one is MS1, and a couple of jumpers over is MS2. And these are to change the automatic motor speed. So you'll notice before I talked about 300 RPM and 360 RPM drives, and the 360K drives span at 300 RPM and the 1.2 megabyte ones span at 360. So if you want the drive to automatically change between the two, then you should select MS2. You should put MS2 on, and the MS1 actually changes the signal from pin 2. Pin 2 is this this second one in, the one right next to the gap here. And who knows why you would want to do this, but if you wanted the double density drives to be spinning at 360 and the high density ones at 300, then you could put that jumper on and it would invert the meaning, so it would spin at the wrong speed. So yeah, you certainly want that jumper off in this case. So the only remaining jumper is the one in between, and that is DR, and this should just generally be closed for drive ready. It's not very important because this controls the function of pin 34, and there were two completely incompatible standards for what this should do. And it goes all the way back to the days of 8-inch floppy drives. Yeah, they had 8-inch floppy drives. And the motors on those just used to run continuously, and so there was a disk ready signal on pin 34. The PC doesn't use this. It actually just waits a second to see if anything happened. So it's a little bit of a strange setup. The other option is disk changed, and so if you have that jumper off, then it will act as a disk change thing, which some controllers will require, but they're very rare, of course. So this enables the machine to tell when the disk is changed, when you actually remove the disk and put another one in. You probably know from your use of PCs that this sort of thing is just not widely used. So just basically leave that jumper on and everything should be fine. So the last drive I want to look at here is the DS53A. At least it's the last drive that I've been able to get to work, and there are a number of companies that make a drive with this model number, and they're basically all the same drive as far as I can tell. This is a Digital System Inc. Drive. Now I've removed the cover off here. There are two screws that you can take out, and then the cover slides out and then off. You can actually get to the jumpers with the cover on, but I wouldn't like that as a day job. So starting at the top here we have a DCRY, and this is just alternative lettering for drive change, drive ready, which we discussed for the previous drive, so I won't go through that again. And DMMM is for changing when the motor comes on, whether it's either the drive select or the motor select pin that controls that, and so I won't discuss this again. That should just be set to MM. And then there is the drive select jumpers, so you have 0, 1, 2 and 3, and of course we just set it to 1, which would be correct for a PC. So finally we have this mysterious jumper at the bottom, IM and NM. Now I don't actually know exactly what this does. A lot of the Japanese drives it's very hard to find documentation for, so if you happen to know, let me know. I have it set for IM at the moment, and that in combination with this jumper up here, the SS2 being off and the IM being on, seems to be correct, at least for a 360K floppy disk. If you set this up as a 1.2 meg drive, which it is in the BIOS, and then put 360K floppies in, that will work. Now, I believe that the IM is equivalent of a drive select, which would mean that you couldn't use this with a second drive in the machine, so perhaps you would have to select NM. But as I say, I really don't know the answer to that. The SS2 seems to be the drive speed select, and again, I don't know whether this selects automatic or whether it just changes the drive speed. Remember again that 360K floppy should be at 300 RPM, and high density ones, 1.2 megs, should be at 360. Now, at the moment I have this set up so that if you run it as a 1.2 meg drive, it'll take 360K floppies. That's the only setting I can tell you that will work on here. I haven't tried all the others. So the other thing that's kind of interesting is that if you set these drives up that have dual speed so that they use the wrong speed, and you can certainly do that with both this drive and the previous one, you can actually pass disks between those drives and they'll work just fine. They just won't work on any other drives. And this is what I had for the longest time, and I couldn't figure out why I could get these drives to work, but then the disks wouldn't work in my XT or in my Amstrad machines. And once I realized that it was actually the drive speed that was causing the issue, and I set the drive speed correctly, then I made a lot more progress. Unfortunately, that wasn't the only problem, so I'll go through what some of the other issues are in a moment. So that leaves two drives which I haven't got completely working. This particular one is a drive that doesn't work at all, and it's really hard to know exactly what could be the cause of that. It makes a horrible clattering noise when it starts up, and the head jumps up and down, and it seems like the motor is trying to drive the head backwards and it's getting stuck. Now I've checked, of course, that there is nothing stuck here. It's almost as if something is wired up backwards, but each of these connectors here can only go in one way. So I don't really know what's wrong with that. If you've encountered this problem, then let me know. This is a YD380B. Now this is a 1.2 meg drive, and there are statements on the internet to the effect that this won't support 360K floppies or double density floppies. But this is actually false. This particular model does support them, according to someone who has one of these. It's the Model C that only supports 1.2 meg floppies, and as the 90s wore on, fewer and fewer 1.2 meg drives supported 360K floppies anymore. So that is a bit of an issue that you might encounter, but at least I don't have that here. Setting this up is dead simple. By now you just select DS1 and that's it. There's nothing else you can change here. And so it's just a shame that this drive doesn't actually work, but at least we know what the jumper settings should be. So the final drive to discuss is this TIAC FD55GFR. And these are actually very common drives, and so we do know the correct jumper settings for this. We just don't know what most of the jumper settings do. So here you have DS0 through DS3, and by now we know how to deal with this. There's also U0, U1, no idea, but neither of these should be jumpered. In fact, the only jumpers that should be on here are this one here, which is presumably drive change, it's DC. Perpendicular angle you have RY, which would be drive ready. And down here there's a jumper called FG, and I have no idea what this does and don't want to take a guess. The remaining jumpers are just a big tangle here that is really hard to figure out which letters correspond to which jumpers. There is an IU, and we know that that is just not used. That's the in use one. And the other ones I'm not even going to try and take a guess at. So the problem with this drive is that it reads one side of the disk no problems at all, but refuses to read the other side, and it just zooms back and forth looking for something and doesn't find anything at all. So my best guess is that the head in this is damaged, and this is why it can't read the drive. I mean, they are very fragile, and perhaps someone over vigorously cleaned it or has dropped the drive or something like that, and it just doesn't function anymore. So you might think that once you have all of the hardware set up correctly, you've got the right kind of cable, you've got it round the right way, you've got the disk on the right end of the cable, you've got the jumper settings correct, you've got the right kind of disk in the drive, it's calibrated correctly, you've cleaned the heads and plugged in the power, that everything's going to work. Well, not so. I actually got stuck for an entire day, and what I had been reasoning is that because I wanted to write 360 kilobyte disks for my XT machine, that I should select 360 kilobytes in the BIOS. I thought, okay, I might have some 1.2 meg drives, but if they support both 360K and 1.2 megs, I obviously want to select the 360 kilobyte option. Not so. If the drive is a 1.2 meg drive, you must select 1.2 megabytes in the BIOS, even if you want to write 360K disks. And the reason is just that it will run at the wrong speed if you don't do this, especially if you have one of these dual speed drives. Now, it could be that you have a drive that only supports 1.2 megabytes, and you're pretty much out of luck if that is the case. There is some information on the Dave's Old Computer website about how to tape over some of the pins on your drive in case it supports dual speed, but you want to force it to use a different speed, but you don't have a jumper for doing that. So I'll let you check that out if that's a problem that will help you with a project. Basically, you can cover up pins 1, 2, 3 and 4. It's really only pin 2 that you care about, but it turns out pin 1 is not used, and all of the odd number pins are ground anyway, so you can cover up as many of those as you want. So this is one way of getting around the problem, but in my case I really just had to select 1.2 megabytes in the BIOS here, and I would have had a much easier time of it. However, the problems don't stop there, and the issue is that there's no guarantee whatsoever that the 1.2 meg standard and the 360K standard are even compatible. Now the issue here is that the 1.2 meg heads are much smaller, and this is because they wanted to write with a higher density. And that's a physical characteristic of the drive which it can't change, and no software is going to help you with that. So the problem is if you write a disk in a 360K drive with the much wider heads, it'll write a very wide track. Now of course these 1.2 meg drives that also support 360s, they are able to jump the correct distance between tracks. That's not a problem. But they're going to write a 1.2 meg style track in the right place but of the wrong width. It'll be much narrower and tends to end up in the middle of the 360K track. So when you take that disk and put it back into a 360K floppy drive with the much wider head, it's going to be reading part of the old track, which is still there on the outside, plus the middle portion where the 1.2 meg head wrote the track in 360K mode. So of course this is obviously not going to always work, and what people have noticed is that if you format the disk in the 360K drive, and I really mean format, not write, and then write the disk in the 1.2 meg drive, then it usually will work back in the 360K drive. But there's no guarantee of this. And obviously the thinking was that people would take their 360K floppy disks, copy them over to 1.2 meg disks, which would be no problem whatsoever, and then they wouldn't have any problems from then on. But of course I want to go the other way. I mean, 1.2 meg drives are so much cheaper, and I have quite a few of them here. I can stick one of those in my Athlon machine and then write to my disks and transfer the data across to my 360K drive. But of course this will work only if I format the disk in the 360K drive before writing to it in the 1.2 meg drive. So I actually had some comical experiences with this. Something else that I want to point out is that if for some reason you get the format of a disk completely messed up, when you format it using, I think it's DOS 5 or higher, you have an unformat option. And so what it does when you go to format a disk is it first tries to check the existing disk format and then save unformat information. Now very often this will just fail entirely and it will look like the disk doesn't work. It'll give you, sector not found errors and all sorts of other issues, which I'm sure you're very familiar with. It turns out you can just ignore these. Just press the I key to ignore until it gets up to the point where it starts formatting the disk. The first time you go through, it'll format half of the disk and not the other half. All you need to do then is put the disk in a second time and format it a second time, and the disk will be fine. So that's an interesting trick. So actually many of the floppies that you've thrown out may not have actually been faulty after all. It might be that you wrote them on a drive that had the settings incorrect. And if you write them on a drive with correct settings and just ignore the unformat part, everything will work out just fine. So I finally got all of my drives except 2 working, and I hope that this video will give you the opportunity to pull out some of your 5¼ inch drives and get some of those working. If that happens, let us know in the comments below. We'd love to hear the stories. And that's basically all I have for you this week. Thanks very much for watching. I hope this has been informative and useful, and we'll see you in a later video. Bye.